quadratic functions and their properties. What we're going to do first is we're going to talk about the two different forms in which you see quadratic functions represented. But let's get into the specifics below here. It says a quadratic function is a polynomial function of degree 2. So that's the first thing to understand here. And then it also says the graph of a quadratic function is a parabola. So parabola is that U-shaped. And if you've seen this before, it opens up, it could open down. Just those ideas are what we deal with. And then we can move this thing around. We're going to do everything we possibly can with these quadratic functions. So what we're going to talk about first are just the two different forms in which we usually see these quadratic functions. So here's the first one here. Now this description calls it the general form, but that changes depending on the book. So I'm not going to get caught on specifics because you're probably going to Google stuff. So I'll be a little careful with that. But this is the form. F of x equals ax squared plus bx plus c. And then it says where a, b, and c are real numbers and a is not 0. Now below here, they call this one standard form of the quadratic function, which I don't know that this book really bends that way. I don't think it does. So I'm going to stay away from those. But here's the other form. F of x equals a parentheses x minus h squared plus k, where a is not 0. So this form down here is sometimes referred to as the vertex form. So if you Google stuff and you see that, don't be alarmed. That's this form here they're talking about. And the reason why is if you look just below here, it says the vertex HK. So that's the vertex of these U-shapes. So it's the tip. And if you look at this form here, right here I see the H and I see the K, and that's immediate. So when it's in this form, I know exactly right away what the vertex is. So we'll get into that more in detail once we get into these problems. But that's why sometimes it's referred to as the vertex form. Now below, we have these two equations here. And if you notice this, they're saying H equals this negative b over 2a. We'll talk about that some too. But if you notice, if I had it in vertex form or standard form that this is saying here, I wouldn't have to worry about using this formula here because I already know the vertex immediately. So what that's saying is when I'm using these equations is when I have my function in this form here. So, and then that's going to give me my h, and then I plug that value into my function, and that's how I get my y value. And that's why they say f of negative b over 2a. So now what we're going to do is we're just going to get into these problems below, and this will kind of help us a little bit to get through some of these instances. But we won't address this issue right away. We'll address that probably in the next video. But anyways, let's get started. It says graph the function f by starting with the graph y equals x squared and using the transformation, shifting, compressing, stretching, and or reflecting. So what I'm going to do here is I'm just going to talk about what that means. Like for a is f of x equals negative x plus 2 squared minus 4. So we're going to get into that right now, but we definitely don't have enough space here, so we're going to move it over here. And I definitely want that space to talk about all of this. So the first thing to notice here is that, notice I have a negative here. So if I know the general function is this way, that negative on the outside that way tells me that I'm going to make all my positive y values because y equals x squared. And if I put a negative on that, it's going to make all my positive y values negative and all my negative y values positive. So this is actually going to flip it over. They call that a reflection. And that's why I say reflecting here. A reflection over the x, because this is the x-axis, this is the y-axis. So the first thing is we get a reflecting over the x. Now the next thing to notice is what's going on inside of here. If you look at the form, which I'll go back to here, notice what they said. It was a x minus h is what they were dealing with internally there. So inside of that, it was x minus h. So that's looks like an x plus h in a way. So I got to make it so I have to make it a minus. So if I rewrote this so it fit the form exactly, this would be minus x minus a negative 2 squared plus 4. So that tells me it would be a horizontal shift, and this is my horizontal shift here. And I actually wouldn't write it that way. I would ask myself, what makes this 0? And I would see that -2 makes it 0. So I know I would shift to the left 2. And since it's inside that power, inside the function itself, that's a horizontal shift. So the next one would be a horizontal shift, and then that's where the shifting comes in, where they're asking in the directions. A horizontal shift of -2 or 2 to the left, a horizontal shift of 2 to the left. Now the next thing we're going to talk about is the +4 here. And if you look at the form there, because this is in that second form, if you look at where that 4 is at, that 4 is this piece right here, the +k. So what that means for us here is that's my vertical shift, how much I'm moving up or down. And since that's a +4, that means I'm going to move up 4 because it's being added to the x squared. So that's adding to the y values, which means it's moving all my y values up 2. So that's going to be a vertical shift of 2. Not a vertical shift of 2, but a vertical shift of 4. Of 4 up. I could say positive, or just 4, or I could say shifts up 4. Oops, let me take that out. That's what I can say there too. Now that's all this one does here. So what I'm going to do now is I'm going to graph this in just a second, but I want to talk about one more thing first. We didn't have any compressing or stretching. Now it's one or the other. So either I'm going to have a stretching of my function or a compression. And that happens when I have a number here besides a 1. So let's say that was a 2. That means I could talk about this being a vertical stretch. And now I'm doubling everything. That's what that would do. So it's a vertical stretch of 2 is what I would say, because it's like I'm taking it, and now a regular one might be this way, and then the other one would be this way because it's going to increase by 2 when I get to 1. So that's the more interesting. So they call it like a vertical stretch because it's like getting more narrow because I pulled it up faster. So that's why they call it a vertical stretch. Now a compression happens if this number in front of here was between 0 and, I should say, between -1 and 1, not including 0, because it can't be 0. And then that would make it a little more wide. So think about it. In general, if I have this function here, when I go over 1, it goes up 1, and it goes up 1 here. That's the general. When I go over 2, it goes up 1, 2, 3, 4, and then I have the same thing going on here. So that's what happens when I'm dealing with a general quadratic function. So now when I'm dealing with a compression, I could say, hey, let's say that was a 1/2 in front of there. So that means when I go over 1, it's only going to be a half. So if you think about it, it's going to look more wide because it's not increasing as fast because I'm only taking half of every y value. So it's going to look wider. So that could be a vertical compression because it's like I'm pushing it downward towards the x-axis. So that's where that comes in. I just wanted to talk about that. So when you see it, you're not completely confused. So what I'm going to do with this one is I'm going to graph the original y equals x squared, and then I'm going to graph the transformation. Now for the other one, we're going to just put it all together now. So I'm going to reflect over the x. So that brings me in this direction. Now again, when I move over 1, I should actually draw this a little bit more precisely, that it's going to go through that 1. So the 1, 1 is now going to be -1, -1. It'll be there. And this point here will now be there. So then I can kind of draw that down. So that looks a little better. We'll get more specific with the final. So now I have a horizontal shift of -2. So that means now this picture is going to be drawn here because I moved to the left 2. And then I'm going to shift it up 4. So from there, that vertex now is going to be 1, 2, 3, 4. So it's going to, oops, excuse me. So it's actually going to be there now. So now I'm going to draw it more specifically and clear all this other stuff out since we know exactly where it's at now. The vertex is now going to be there. And then when I go to the left, it's going to go down 1. And when I go to the right of it, it's going to go down 1. And then when I go over 2, it's actually going to go down 4. So it's 1, 2, 3, 4. So it's going to be right here. So then the other one, we're going to have this symmetry here. It's going to drop here. And then when I go out 3, it actually goes out 9. So 5, 6, 7, 8, 9. So it'll be there. And then the same thing on the other side, I have that symmetry. So when I go, did I do that right? Let's see, 1, 2, 3, yep. And then that's going to be 3 the other way. So 1, 2, 3. So it puts it here. And then I could actually probably go out another, but I don't need to. That's enough. Because I can get a nice curve here. Oops. And there's my actual graph there. And the thing is it said graph the function f by starting with the graph y equals x squared. And that's what I did. And then I actually wrote the description down of what I was actually doing there. And that really helps in the process of picturing the graphs and actually just graphing them. And this is a very specific graph. Everything's right. Now, if there was a number in front of there, like when I move over 1, that's when that would not necessarily be a 1 down. Here, if that was a 2, it would have been a 2 down, which would have gave it, again, another vertical stretch. So just kind of be aware of those things too. This one wasn't that involved. But we got the next one we're going to do in the next video.